So this video is for section 6 of the level 2 ICT BTEC in computing unit 2 technology systems. So in this unit, in this section, we're going to be talking about software, different features of software that you should be aware of when you're either designing it or buying it or building it or commissioning it if you're the user. So, in this unit we categorise types of software into two broad categories. One is what's called off-the-shelf and the other is custom-made. Off-the-shelf doesn't literally mean it comes off the shelf. What it's talking about is that it is bought as is. You buy the same as every other customer. So a really good example, an obvious example, is Microsoft Office, where you just buy Office. Or a game that you buy, like Animal Crossing, whereas for example, a holiday company, a tourism company, might ask for a designed system specifically for the type of business that they do, with just those screens that they need, just to fit the needs of their customers. The NHS, for example, uses a bespoke or custom-made system, which they're developing right now, which will enable records to be transferred instantly between different departments. At one time they were developed separately, so you would go into A&E and you'd get your X-ray done, and they'd put your paper X-ray into your chart, and they might decide that you needed to come in for a stay because they'd found something that wasn't good, and you might be taken up to the cardiac department, for example, and they would then start a new record of your information. But of course they had to wait for the old record to be brought back, and every time you moved it was very difficult to find you. These were turned into electronic records, but separately, so the needs of different departments were individually built into the system. The NHS is currently building a bespoke system which will put all of the client's needs all into one place, so that all the records transfer and make sense between departments. So you can see why a custom-made program, piece of software, might be useful. Off the shelf obviously is quite cheap. It's being made thousands of times, so they just get their profit on every single individual sale, so the profit only needs to be small on each one. Whereas for custom-made software, this is very expensive. It's been built specifically to your needs. You will possibly be the only or one of very few customers, and therefore it's far more expensive. Off the shelf has been tested thoroughly. It's been used millions of times before, so bugs are rapidly reported and they will have been tested thoroughly before. Whereas for custom-made software, they can only test it on cases that they believe are likely to occur, and it's probably after it's become live that more examples of using may bring up problems. Obviously, off the shelf is supported well by books, forums. I know some of my students were recently saying they wanted some training in a particular piece of software. Even though that isn't particularly well documented, there are at least some resources. Whereas if it's custom made, then the client or possibly the software developer may have to produce the support that's needed. I in the past have written custom-made software for clients, and I know how important it is that you develop documentation for the client. They, usually being less technical, will often forget that features are there or not understand how they should use it. So and they haven't got anywhere else they can refer to. Obviously it's quick and easy to purchase and install off-the-shelf software. You just buy it and install it, and the instructions are very clear. If you are having something custom made, like the example of the NHS, it is taking them years to develop that. A project I used to work for was a life assurance company, and that project again was taking years of small developments and improvements just to make the software for that one company. But of course, the off-the-shelf software, it may miss features that you would like. Quite often people are using Office and say, oh, I wish it did something or other. But on the other hand, it won't have extra little twists and turns that you normal customers don't need. On the other hand, custom-made software should do exactly what it's been designed to do. So it's clean and it's usable because it doesn't have all sorts of extra whistles and bells and menus that you don't need. However, after being used, it might become clear that there are extra features that are needed, and those won't be in it. So the operating system, it's something we don't really think that much of, but it's an important, very important piece of software. The operating system is what sits underneath, just over the top of the mechanics of it. I've talked before about how the ROM, read-only memory, is a bit like when you wake up and the first few inklings of where you are, what you're doing, where you are, what day it is. Though that's like the ROM, the read-only memory, the chip that's inside the computer. The first piece of software that the ROM often picks up is the operating system. So the operating system is the manager system in the computer. It will it has several functions. One of those functions is as a file manager. I, for example, in Windows, I have this series of files. I can go into different folders. I can move files. I can rename the files. All of that is a feature, a function of the file of the operating system that comes with, in this case, Windows. Other operating systems you've probably heard of before are Linux. Linux is open source, so it's free. Did I say Linux or Linux? It's Linux is open source, so it's free. I'm talking about the software that we talked about in the here. Microsoft Office, Microsoft Windows and Linux are both off-the-shelf software. You buy or you download Linux, or you buy Microsoft Windows, along with thousands and thousands, millions of other users, and you buy it as is. So file management, you can copy files, you can move files. Of course, another operating system was DOS, a disk operating system. Does exactly what it says on the tin. And I'll talk a little bit more about that when we come to the graphic user interface. The next function of operating systems is their hardware management. So perhaps we should think of operating systems as the foreman at a office or factory or hotel, And one of the things that the Foreman is doing is telling people where to go, file management. The next thing is the hardware, so maybe as cars drive in, the Foreman tells people what that piece of machinery or what that car does, where it should go. So the hardware manager of the operating system is the thing that enables the keyboard and the printer, for example, to talk directly between the processing and the hardware itself. We use drivers for that. The operating system usually comes with some default drivers that will work for most hardware, most standard hardware, and then you can also download specific drivers extra for specific features that may not be in standard pieces of hardware. So without the operating system, the keyboard, for example, cannot send its signals to the processor. There needs to be something to translate and to talk between the two and to manage who gets how much time of the processor. So that leads us to the next role of the operating system, which is to resource allocation. So constantly there are hundreds of operations being tried at the same time. So for example, if I move this folder into your view, you can see that I'm moving my mouse. I'm also, by doing that, the image is changing. At the same time, I'm recording the sound and this video. So my mouse, my screen, my camera, my microphone are all trying to do work at the same time. So what the operating system does is it allocates time. It allows time for each of those pieces of hardware or each of the softwares to run so that to us it looks like they're all happening at exactly the same time. What's in fact happening is that the operating system is cutting off very short pieces of time to each of those actions in a rota. It's allowing those with the most priority to get the most time, and it's allowing it for me or for us to look as if all these actions are happening at the same time. But in fact, that's down to the operating system cutting in and cutting out of hundreds of activities. And then I've also talked about the components of the computer and the memory, your RAM or your local memory on the motherboard needs to be allocated. So again, if I am trying to move something on my screen like this, that would take a lot of processing and a lot of calculations for it to work out constantly where the image should display. If I'm not careful, my short-term memory, or the thing I think of as my whiteboard memory, would get filled up with those calculations, and it then couldn't carry on with the other calculations, like how it makes the record of the sound and how it keeps the image of the camera and all those sorts of things. So it has to be fair and share it out. And one of the final roles of the operating system in this context is security. So you know from using Windows at college that it is important for giving you access, so you have to log in. It will only let you in if your username and password are stored on the system. It will also make sure that only those who are allowed access to certain features, certain files can get access. So on the college system, the K drive is a drive that I can both read and write to, whereas students can only read from There are certain drives that you don't see. And for example, the H drive is unique to each individual student or lecturer. So all of that is managed by the operating system. It also operates utilities such as antivirus and firewall. So the antivirus will check files that come down to make sure that there aren't any patterns in them that lead it to believe that they are a virus, and a firewall checks to make sure that the only those allocated to access system are allowed in. So we've talked briefly about that. Just is anything extra to add? Oh, one final thing, disk defragmenting. What happens in a memory, in particular old memory such as magnetic memory, new data, whether it's software or whether it's your files, gets put on in the most efficient way into as big as chunks as possible. So a new disk everything will be installed continuously. What happens obviously over time is you delete files, leaving small chunks of space. And so when you then start putting new files or new software onto your disk, it has to break it up with little flags to tell it where to find the next part. So it might be spread into thousands of small parts. So to run a piece of software, it might have to keep jumping across to different parts of the disk. What can even happen is you can end up with thousands of tiny sections. What a disk defragmenter does is it finds all the spare places and it then tries to shift everything tidily back into bigger sections to make reading the data much faster. User interfaces. Okay, so I said I'd mention another operating system, so DOS. You've probably seen the command line, which you can bring up in Windows and allows you to do certain features with typed in commands. This was the original operating system and it worked entirely through this command line. Everything had to be typed. That meant that you needed to know every instruction and you had to type every instruction correctly. So you had to be quite technically skilled. Then along came Windows, which was it's argued whether it was the first, some say Linux was the first, but an early graphic user interface, GUI, graphic user interface. And what that meant was that the user interface, the user connection with the computer, was graphic. So that brought along the mouse. The mouse meant that you could move things without having to type, and you visually saw what was in certain folders and you could drag things. So it contained windows and icons and menus and of course pointers, and that's known as WIMP. This was at the time a huge breakthrough, being able to actually physically just use a mouse to drag things, and since then we've developed that far beyond that. So we now have things like I built this presentation using speech recognition. Screen readers mean that people who are unable to see, the data can be, the words can be read for them. It's easy to use. even for a novice, whereas the command line interface like DOS, you had to be instructed what was possible and how to do those things. With a graphic user interface, it's far more intuitive. And since the onset of mobile device systems, the user interface has changed even further. So there is obviously no mouse, the screen is much smaller, so it has to be designed with that in mind. So the GUI has to be optimized for that. So for example, now we use a finger instead of a mouse, and in, of course, more recent versions, speech recognition is really common. It has hugely opened up the accessibility for people with disabilities. For example, touch surfaces are much easier for people with mobility issues. On my texting and WhatsApp, I use swipe, so I don't even have to individually type, I just swipe across the screen. And gestures can be really helpful. A lot of them are very intuitive, like if you're pulling something, you make it smaller, or you open it up, make it bigger. Although I was listening to a podcast about the Next Billion Users, a project from Google this weekend, and it was saying that these still aren't as intuitive as we might think. And design now is looking at how those who have never used technology before, that next billion users, how they will be helped, how that can be made even easier. So then we need to talk about productivity applications. So by this we mean things such as software, Office software. You've all used Word or an equivalent, spreadsheet, PowerPoint, things such as that. These are productivity. These are for us to produce new pieces of work. They're not games. They're for us to produce some form of work. Graphics software, vector graphics and raster graphics. So vector graphics, in this type of graphic, the image is developed by the computer knowing the path of lines and shapes, and then drawing the image based on those paths between 2 points. So if I drew a circle, it would know the radius of the circle and the colour to make it, and where the radius begins. Just those 3 pieces of information, it could draw the circle. That's vector graphics, and used often in logos, things like that. Raster graphics, on the other hand, is where every individual dot of colour is recorded. So, for example, if I drew a circle as a raster graphic, what would happen is that every individual dot in that circle, it would be black, 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 red, 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 black, 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 red, 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 black, 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 red, black, 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 red, 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 black, black, black. So individual dots are coloured. This obviously is appropriate for photographs because they're not predictable, they're not geometric. One thing to be aware of is that with vector graphics, these are what's called sizable. So because it's done on the path on where a very few individual points are and where things between those points are, it doesn't matter if it's a tiny image or a gigantic image, the path is just as clear. Whereas with raster graphics, for example bitmaps, if you try to enlarge a small image, you'll notice that the image begins to fail because it only knows that number of dots. And if you make the image bigger, it wants more pixels in between, but you don't have that information. Other productivity applications are web authoring tools. So often this is done online now. We've used Weebly, there's GoDaddy, Wix, things like that. But also there are other ones such as Atom, which you can download. A keyword to be aware of is WYSIWYG. We are so used to this now that we assume this would be true for everything. What this means is what you see is what you get. An example of this is the old days. Let me just see if I can. In days gone by, what would happen is that you had to type in your formatting instructions. So you can see here I'm saying it will write justify, it will write justify, it will write justify dear, bold, Peter, end bold, you have 1A, bold, giant teddy bear, end bold. So very difficult for me to see that instruction, to see that as I've written it. What you see is what you get. You can see here it is simply justifying on the right, and it is simply emboldening. This is very true. A very good example of this is when you build web pages. So most, particularly online developers, now are WYSIWYG, and what you see is what you get. You just drag and drop. Whereas in the past, what is useful to understand when you are doing web authoring is the codes that sit behind it, the HTML and the CSS, and they look very similar to these instructions I've typed here. It tells it where to make a level 1 heading, a level 2 heading. A image won't show up when you look at the code. You simply see the instruction of what the image will be, but no image in its place. And finally, when you are upgrading and installing new software, here are the 6 factors that you ought to put into thinking if you are considering it. So what should you think about? Well, you need to think about whether your hardware platform will can install this software. A really obvious example of this would be if you have just bought a game. Some games will only run on PlayStation of various levels, or the Switch. Obviously, you cannot buy Animal Crossing for PlayStation. It doesn't exist. So that's a really obvious example. Another example might be that you may need a particular piece of hardware to run that program. For example, do I have a drawing tablet? If I don't have a drawing tablet, how will I best be able, is it a good piece of software for me? And also, of course, the other things are, which we'll come to, is it high enough level? Does it have enough processor, like that? No, I can't think of another example. Accessibility features. There are laws now which say that if we give an environment to one person, it has to be accessible to people with disabilities. This is very true, and we look at this when we build web pages, but this is also very true with software. So if we find that a piece of software does not have certain accessibility features, touchscreen on a phone or something like that, we might think twice before we use that. Other things such as speech to text and text to speech. So me speaking and it typing onto the screen. But alternatively, Microsoft Office has immersive reader, which allows you to highlight text and it will read it out to you. Those two really key accessibility features. Will the software be compatible with the system that you already have? Will it be compatible with the files you want to run? In the good old days, there were a number of different word processors. We still now use Google, and we use Office a lot. And some people have older versions of a different Microsoft Office program, and they might find that the program that they have just bought won't open files from either using a different program to do the same job in the past or an older version of the program. Most software is backward compatible. What that means is that most software, if I buy Word now, it says it will read all past versions of Word documents. Whereas if I now transfer across to Google, I might find that certain features are not compatible and just don't show up or work wrongly. Other features you're looking at are cost. Is this a reasonable cost to spend on this software for this purpose? Speed is really important. When Windows, I think it was Windows version 8 came out, it was seen as just an appalling version, and one of the big failings it had was it took up way too much memory. It was way too big, so your hard drive was clogged up, and maybe you couldn't add any more software, and also it was really, really heavy on the processor, so its speed was very, very slow. And of course, you also want to be looking out for security features. So if I write a program in Word or any Office program, I know that I have the ability to lock that document and put a password on it. And I also know that using the the operating system, I can make further security features on that. So that I think covers the material here. It's really, really important with these, particularly with a lot of this discussion based information in this one. This is where you're going to get those higher marks from discussing those factors. You want to say why, because this is a feature I look out for, because this is a feature I look out for, because if I'm going to recommend upgrading a piece of software to my manager, I would recommend it has accessibility features such as speech to text, because we have a requirement to support people with disabilities, but also this will be a huge benefit to every user. When I in the past have recommended software to my manager, one of the things I've considered has been, particularly where there's options, what to choose, cost has been one of the key features. So if I were recommending a piece of image editing software, there are a lot of different versions. There are a lot of free versions, but then I might find that those are perhaps not having as many accessibility features. So it's weighing up factors, and that's that discussion that will get you those higher marks for those higher marked exam questions, those 6, 8 and higher mark questions. I hope that's been useful.